Alright, so in this video we're going to go over more connected rates problems, but this time it's going to be related to geometry, it's going to be related to shapes rather than coordinates that we did before. So alright, so the idea is the same. A circle has a radius of r centimeters and an area of, so just highlight all your important information. So you are given your area and your radius in r in centimeters. The radius is increasing at the rate. So dr by dt, right? Your radius is r and your radius is increasing. So the change in radius with respect to time, because it's per second, is 0.1 centimeters per second, right? Or centimeters second to the power minus 1. All right, find the rate of increase of area A when r is equal to 4. So we want to find dA by dt. And we don't know what this is. All right, so we know the area of a circle is pi r squared, right? So what is dA by dt? dA by dt is just dA by, what is, now we have a with respect to, defined with respect to r, right? Our function a is defined, our area is defined in terms of the radius. Previously, we had y defined in terms of x, right? And what we did dy. So when you wanted to differentiate this with, sorry. That is wrong. Okay, I wanted to differentiate this with respect to time, I did dy by dx times dx by dt. And these were canceling out, right? I had y in terms of x. Now I have a in terms of r. So it's going to be dA, y is here. Now it's going to be dA by dr, which is the variable here, times dr by dt. And remember, these have to cancel out again. So now I need to find dA by dr times dr by dt. Now what is dA by dr? Well, I just differentiate this equation with respect to r. So dA by dr is now pi, I keep pi, and if I differentiate r squared with respect to r, if I differentiate x squared with respect to x, that is 2x. So now this x is just now r. So it's going to be 2r, right? The variable is the same. So I'm going to get 2r. So dA times dr, so that is dA by dr times dr by dt. And we are given dr by dt in the question. Sorry. So that is just 0.1 centimeters per second. So pi times 2r and dr by dt is 0.1 centimeters per second. And now we need to find it at r is equal to 4. So just substitute 4 here, and that is going to be dA by dr. So you substitute 4 here, you are going to get 0.8 pi centimeter squared per second. And that is going to be your final answer. So your answer is 0.8 pi, and 0.8 is just 4 over 5 pi centimeter squared per second. Because why? R is 4 centimeters, right? So you are substituting 4 centimeters. So centimeters times centimeters, centimeters squared per second. So your units, you have to be careful with your units as well. So this is your answer. And sorry, there's a rimdo going on nearby. So 4 over 5 is 0.8, right? So this is your answer, dA by dr. All right, so we are done with question 1. And most of everything else is going to be very, very similar. A sphere has a radius and a volume v. So remember, volume of a sphere is just 4 over 3 pi r cubed, right? That is the volume of a sphere. And now we have v with respect to r. So dv by dr, if I differentiate this with respect to r, is going to be 4 over 3 and pi are constants. So I just differentiate r cubed and I get 3r squared. And 3 and 3 will cancel out. So I get 4 pi r squared. That is dv by dr. And the radius is increasing. So we are given dr by dt is 1 over 2 pi centimeters per second. So I encourage you to write your units because it's going to matter, right? Find the rate of increase of the volume when v is equal to 36 pi. All right. So we want to find dv by dt, rate of increase of the volume, right? And that is going to be dv by dr because v is defined with respect to r, and times dr by dt. Why? Because these dr and dr will cancel out. So I will be left with dv by dt here. Now I know what dv by dr is. That is 4 pi r squared And I know what dr by dt is. That is 1 over 2 pi centimeters per second. So let's simplify this first. Pi and pi cancel out. 4 divided by 2 is going to give me 2r squared centimeters per second. Now, I don't know what my r is, but I am given volume is 36 pi. So I can substitute this here. So 36 pi is going to be 4 over 3 pi r cubed. So let me close the window. I think that will help. All right. So 36 pi is equal to this expression, right? So if you multiply by 3 and you divide by 4, I think you are going to get 27 pi is equal to pi r cubed. So I just multiplied by 3 on both sides and I divided by 4. So 36 by 4 times 3 should be 27 pi. And pi will cancel out. So r cubed is 27. And if you take the cube root, you're going to get r is equal to 3. Because 27 is just 3 cubed. And no, it cannot be negative 3. Negative 3 cubed is negative 27. It only works when you have an even power, the concept that we talked once before. So now you just substitute 3 here. 2 times 3 squared. But what is 3? 3 centimeters. Radius in centimeters. So 3 centimeters squared times centimeters per second. Okay, I'm so sorry. It disappeared. It's going to come back. Okay, here. So 2 times 9. Sorry, 2 times 9. 3 squared is 9. Centimeters squared times centimeters per second. Because centimeters squared is going to give me centimeters per second. So I have 18 centimeters cubed per second. And that is your answer. So your units are very, very important. And understanding the question is very, very important. And we are done with question 2. All right. Question 3. A cone has a base radius. So let's just draw a cone. A cone looks something like this. We have a base radius r here. And a fixed height. So this is going to be my height of 30 centimeters. So we are working with centimeters here. The radius of the base, so dr by dt, is increasing at a rate of 0.01 centimeters per second. So remember, my units are in centimeters per second. If it says rate, that means with respect to time. That is why I'm talking about dr by dt. Sometimes we will have to differentiate with respect to the length, with respect to another variable. So that boils down to what the question is asking for here. So I am given dr by dt. Find the rate of change of the volume when r is equal to 5. The volume of a cone is 1 over 3 pi r squared h, right? It's 1/3 of the volume of a cylinder having the same height and the same radius. So that is the volume. All right. So now, it has a fixed height of 30 centimeters. So let me just substitute 30 here. So if I substitute 30 centimeters here, then I am going to get 30 divided by 3. That is 10 pi r squared. And I have my units centimetered here. I am going to get centimeter squared from r squared. And that will give me centimeter cubed, which should be the units for volume, right? So I have this expression for my volume. And remember, V is defined with respect to R again. So dV by dt is going to be dV by dr times dr by dt. So r is my independent variable. So let's find dV by dr first. So that is just going to be 10 pi. And you differentiate r squared with respect to r, you get 2r. So that is going to be 20 pi r. So now let's just substitute 20 pi r here. dV by dt is just 20 pi r. And what is dr by dt? That is 0.01 centimeters per second. And now if you solve this, it says r is equal to 5. So just substitute 5 here. You get 5 times 20 is 100 times, this is 1 over 100. So actually, these will cancel out and you will get pi centimeter squared because r is 5 centimeter. Sorry. Okay, I missed a unit somewhere. So let me think where I missed that. Because I have centimeters here, right? So this is dV by dr. So this expression was dV by dr, which is 20 pi r. Overall, okay, I missed the units somewhere, but because it's change of volume, then your final unit should be pi centimeters cubed per second. So that is going to be your final answer. And let me just go back to check where I missed the units. So this is your final answer. All right. So let me think. Okay. So dV by dr, your units get preserved when you differentiate, right? So you have the centimeter here, and you have centimeter, one more centimeter here, and one more centimeter here. So you get centimeter cubed per second. So because it's volume, your final units are going to be centimeter cubed. So in the answer, you can just directly say, okay, it's going to be, change of volume is going to be centimeter cubed per second. So that's fine. If you can't keep track of units, it's all right. So it's pi centimeter cubed per second. All right. So a square has a side length of x. So we have a square. And remember, a is just x squared, right? If your side length is x, then area is x squared. And x is in centimeters. So the area, so dA by dt, is going to be 0.03 centimeter squared per second. And find the rate of increase of x when a is 25. All right. So we know if a is 25, then x has to be 5, positive, because we are talking about lengths. Lengths cannot be negative, right? So we have this expression. Now remember, dA by dt is just dA by dx times dx by dt. Why x? Because now I have my variable x here. What is dA by dx? You differentiate this with respect to x, you are going to get 2x. And dx by dt, do we know dx by dt? No. All right. But we know dA by dt. dA by dt is 0.03 centimeter squared per second. And now let's substitute x. X is 5, so I will get 10 here. And if I divide by 10 on both sides, 10 centimeters, right? Because I had 2x and x is in centimeters. So I have to substitute 5 centimeters. I get 10 centimeters here. And centimeters will cancel out with 1 centimeter here. So your final answer for dx by dt has to be 0.003 centimeters per second. That is it. So this is your answer, 0.03 centimeters per second. That is the, find the rate of increase of x, so dx by dt. All right. Question 5. A cube has side length x centimeter and a volume v. So a cube, something like this, it has x, x, and x. So volume is just x cubed. So now, because v is defined with respect to x, it's going to be useful to find dv by dx. And that is just 3x squared. All right. So volume is increasing at this rate. So we are given dv by dt is equal to 1.5 centimeter cubed per second. And find the rate of increase of x when v is equal to 8. So substitute v8 here. And I am going to get x is equal to 2. To what? 2 centimeters. That is my side length. And now dv by dt is just dv by dx times dx by dt. These x's will, dx and dx cancel out in theory, just to help you remember, and we get dv by dt, right? Why dv by dx? Because we are defining v with respect to x. So now I have 3x squared and dx by dt. I don't know. We are looking for dx by dt, but dv by dt is 1.5 centimeter cubed per second. Dx by dt. Now let's substitute x is 2 centimeters. And if I substitute here, I get 12 centimeters squared dx by dt, right? 2 centimeters, I substitute, I get 4 centimeters squared. So I get this expression. And now 1.5 divided by 12, that is going to give me 0.125. I have centimeters squared. You do minus 2 on this side if you divide by centimeter squared. That is a way to think about units. Probably not mathematically correct, but it helps. And that is dx by dt. And we are done. That is your answer. Because it's asks us to find the rate of increase of x. So dx by dt is just this expression. And we are done with question 5. Almost halfway there. Question 6. A solid metal cuboid. A cuboid is this shape, right? So I'm very bad at drawing, but bear with me. So this is a square, and then that is a length, or however you want to think about it, has x by x. So this is x, this is x, this is the square face, and this is 4x is heated, and the volume, okay, so volume of this cuboid is x squared times 4x, right? You find the area of this squared face, and then you multiply by the length, and that is going to give you the volume. This length, if you just make this shape upright, you're going to get this. So you have x, x, and 4x. So area of base is x squared times height is 4x. So you get 4x cubed. All right. So we are given dv by dt is equal to 0. Because volume increases at a rate of this. So 0.15 centimeter cubed per second. And find the rate of increase of x when x is equal to 2. So we want to find dx by dt. All right. So it's useful to find dv by dx, right? Because v is defined with respect to x, and that is going to give you 12x squared. You bring 3 to the front, you get 4 3s are 12x squared. All right. So now we want to find dv by dt. That is going to be dv by dx times dx by dt. This is just using the chain rule. Now dv by dt is 0.15 centimeter cubed per second. dv by dx is 12x squared, and dx by dt is what we are looking for. And we can substitute x is equal to 2 here. So if I substitute x is equal to 2 squared, 2 centimeters squared is going to give me 4. So overall, I am going to have 48 centimeter squared here. Not cubed, squared. And dx by dt. And finally, if I divide by 48 centimeters squared on both sides, I am going to get... So if I write it as a number, it's going to be this. If I write it as a fraction, it's going to be this. And remember, change of length with respect to time. X is a length, is a side length here. So it's going to be 1/320 centimeters per second. So both of these answers are correct. One is in the decimal form, the other is a fraction. It's both the same expression. All right, so we are done. Question 7. A closed circular cylinder. So just draw a cylinder, and it's closed. That means both sides, it's closed. There is material. There is like the area of circle matters here. So it has a radius r, surface area a. So we are given the expression for the surface area. This is 2 pi r squared plus 400 pi over r. All right, so we don't need to make the equation. We are already given the equation. So this is a defined with respect to r. So it's going to be useful to find dA by dr. So if you differentiate this, you keep 2 pi, you differentiate r squared, you are going to get 2r. Plus you keep 400 pi. If you differentiate, so this is just 400 pi times 1 over r, right? And if you differentiate 1 over r, you're going to get negative 1 over r squared. So finally, I leave you to do the differentiation on your own. You get 4 pi r minus 400 pi over r squared. That is dA by dr. Now if you want to find dA by dt, that is just dA by dr times dr by dt. So given that the radius of the cylinder is increasing at a rate of this, so we are given dr by dt. Find the rate of change of a. So we are asked to find dA by dt. So dA by dr, just 4 pi r minus 400 pi over r squared. dr by dt is given, which is 0.25 centimeters per second. All right, so now we want to find it when r is equal to 10. So just substitute 10 here. And you will get, if I substitute 10 here, remember, what are we substituting? 10 centimeters, right? So if I substitute 10 here, I'm going to get 40 pi centimeters minus, if I substitute 10 here, 10 squared is 100, 400 divided by 4 is just 4 pi centimeters per second. So that is going to be 36 pi times 0.25, and centimeters times centimeters. So centimeters minus centimeters is just centimeters. Centimeters times centimeters is going to be centimeters squared per second. And that makes sense because change of area has to be centimeters squared per second. So now that is just going to be 9 pi centimeters squared per second. And that is your final answer. All right, we are done with question 7. And it's very easy. So if you understand the question, these questions are very, very easy for you to do. Question 8. The diagram shows a water container. So this is a water container in the shape of a triangular prism of length this. All right, so let's just use this diagram here. This is an equilateral triangle. The vertical cross section means if you cut like this vertically, then you are going to get an equilateral triangle. So this part is an equilateral triangle here. So all three sides are equal. So let's call the sides x. And let me investigate this side. You have x, 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 and there's water up until the point h. And this length is 120, right? So this is 120. All right. So this is whatever. Let's wait for now. So we show that the volume of the water in the container is given by 40, this expression. Okay. So now, what is going to be the volume of the water here? Well, it's going to be the area of the triangle formed by the water. So area of the triangle formed by water times 120, right? Centimeters, right? So it's going to be times 120. And we'll assume the units to be in centimeters. So we are working in... So what is the area of the triangle formed? So let's investigate the triangle, right? So we have x, x, x. So what is the area of... And we know that we just are concerned. This is not x, actually. If I say that the length of the big triangle is x, the small triangle is actually also an equilateral triangle. This small triangle here is also going to be equilateral. This is also equilateral. All right. So let's just call it the length, say S, S, and S, right? So what is going to be the area of this triangle? Well, I can find the area of this triangle. So area of the right angle triangle, which is easy for me to do, and I can multiply it by 2. So I'll get the area of the full triangle, right? So that is going to be 2 times, what is the area of the right triangle? It's going to be half base times height. So these will cancel out. So it's just going to be base times height. What is the base? Base is going to be half S, right? Base of the right triangle. Half S and half S together will give me S. So the base is just half S and the height is just H. All right. So now, can I write S with respect to H? I can, but here you will need to use some trigonometry knowledge, right? So you have this right angle triangle that we are considering. We have this H, this is half S, and because this overall was an equilateral triangle, your angle here is going to be 60 degrees. This is 60, this is 60, this is 60. But now, because we're only considering half of it, this is going to be 30, and this is going to be, you know, the right angle triangle. So now I know that tan of 60 degrees, right, tan of this angle is opposite over adjacent. So tan 60 is square root of 3, if you remember your trig values, and 2h over s is what you're going to get. So, or another way to write this is going to be half s. So now you can rearrange. You can solve for s is just 2h over root 3 and substitute s here. So half s is 2h over root 3 times h. So these will cancel out. You get h squared by root 3. That is the area of your triangle. And now we need to multiply it by 120. So now volume, that is the volume of the water, right? So volume is going to be h squared by root 3. That is the area formed by the water times 120. And now let's think about 120, because 120 I can write it as 3 times 40, right? So now if I simplify this, 3 is just square root of 3 squared. So this and this cancels out. So I get 40 root 3 h squared. And I think that is exactly what the question asks here. So we are done. So I hope that was clear. So I just take this equilateral triangle, I split it in half to find its area, and I have to use some simple trig ratios, and I can solve for S, and then I substitute it back, I get this expression for the area, and then I substitute it to find the volume. So now we have shown A. So now let me erase everything. Because the question, I already gave you the idea, the question gives me things here. So V is just 40 root 3 h squared. So if you're ever not able to prove this, you can always use this to solve part B. That is what Cambridge likes to do. It gives you hints, right? Okay. So find the rate of change of h when h is 12. So we want to find dh by dt. All right. First of all, we know v is expressed in terms of h, so it's helpful to find dv by dh. So you keep 40 root 3, and then you differentiate h squared with respect to h, you get 2h. That is going to be 80 root 3 times h. Now dv by dt is going to be dv by dh times dh by dt, right? Using the chain rule. And because v is defined with respect to x, I'm going to do dv by dh. dv by dh is 80 root 3 times h. dh by dt is something that we are looking for. And dv by dt is given here. Why? Because think about it, water is poured into the container at this rate. That is gonna be the rate that the volume of the container is changing. So you just substitute 24 centimeter cubed s minus 1. All right. So I'm gonna exclude the units here. So I'm just gonna use 24. And remember, if you're finding dh by dt, then height is one-dimensional, right? It's just centimeters, so it has to be in centimeters per second. So this is going to be our final units. Just analyze dh by dt. So now h is given to be 12. So if I substitute 12 here, then I'm going to get 24 divided by 80 root 3 times 12 is equal to dh by dt. So now 24 by 12, that is going to give me 2, and that is going to give me 1 over 40 root 3. So finally, your answer can be 140 root 3. Your unit has to be centimeters per second, and that is the rate at which your height is changing. And we are done. And if you actually rationalize, so usually we don't like keeping your square root terms in the denominator. So what we can do is we can multiply the numerator and the denominator by root 3. Square root of 3 times square root of 3 is going to be just 3. And 40 times 3 is going to give you 120. So this is also a valid answer, centimeters per second. All right, so we are done with question 8. Question 9. So we are given a hemispherical bowl. So it's basically half of a sphere, right? So we are given the volume of the water in the bowl is given by V is equal to 5 pi h squared minus 1 over 3 pi h cubed, where h is the side. So I am guessing they want us to find dv by dh. No. So, okay, so we are asked to find dh by dt in both cases at different values of h. All right. So v is defined with respect to h, so we can find dv by dh. And 5 pi, we keep h squared. If you differentiate, you're going to get 2h. We can keep minus 1 over 3 pi. H cubed, you differentiate, you get 3h squared. Now if you simplify, you get 10 pi h minus pi h squared. All right. dv by dt is dv by dh times dh by dt. Remember, dh and dh will cancel out, leaving you with dv by dt, which is what you have here. And we write it as dv by dh because v is defined with respect to h. So now I can just substitute. I know dv by dt is given to me in the question. Here, 3 pi. I will not write the units anymore. So radius is 5 centimeters, right? So do we really need the radius? Because everything is given. Okay. So dv by dh is just 10 pi h minus pi h squared and dH by dt is what we are looking for. So now let's solve this for the first part, part A. We just solved this for h is equal to 1. So now I substitute h1. I get 10 pi here, and then I get pi here. So finally, if you solve, you are going to get 9 pi here. Pi will cancel out, so you get 1 over 3 dH by dt. And 1 over 3, because h is height, so one-dimensional centimeters, divide by time, 1 over 3 centimeters per second. And now, another expression, I just copied this expression here. We want to solve it for h is equal to 3. So I substitute 3 here. I get 3 pi equal to 30 pi minus 9 pi, right? This becomes 30, this becomes 9 pi, dH by dt. So this is just 21 pi. Not 21 pilots, but okay. 1 over 7 is going to be dH by dt. And remember, h is height, that is one-dimensional, so your units are going to be centimeters per second. And we are done. So the radius was actually not helpful at all to solve this question because they already gave you the expression. So we are done with question 9. Question 10. The diagram shows a right circular cone. Okay, we are given the diagram. So the cone is initially completely filled with water. Water leaks out the cone through a small hole at the vertex. So there's a hole here at this rate. Now water leaks. Your volume is decreasing. dV by dt is going to be negative. Because water leaks means your volume is going to decrease. The level of water is going to decrease. This is going to be negative 4 centimeter cubed per second. So I'm just going to use negative 4 and we'll figure out the units at the end. So show that the volume of water in the cone when the height of the cone is h is given by this formula. Alright, let's think about the volume, right? So your volume of a cone is 1 over 3 pi r squared h. So now we just wanted to write it in terms of h, right? So let's think about this. So I have something like a triangle. So if I just split this cone in half, I have a triangle, right? So I have sort of a triangle, right angle triangle here. So this is the height of my cone. This is my radius, right? And radius is given to me as 10 centimeters. The height is fixed, is 30 centimeters. But that is initial. So instead of h, so the radius of the cone, right, is going to change. So we are going to have this. We have h and r. So let me draw it like this. Okay, this is, I think, more helpful. We have our cone, right? So this is going to be our cone. This is our cone. And this is our radius. And this is our height. And we know r is 10 centimeters and our height is 30 centimeters. Now water is leaking out, right? So let's say this is the water level. The blue is my water level. So we have our new height and our new radius. It's going to be smaller. Both the radius and our new height is going to be different from the big cone, right? Because the water level has decreased, it's going to form a smaller cone. But these two triangles are similar. And that is the idea. So the ratio of the similar sides has to be similar, right? This is equal. They have the same ratio because these are similar triangles. So r dash divided by r is going to be equal to it's going to be equal to h dash divided by h. The ratio of corresponding sides is equal for a similar triangle. So that is the key idea here. So what is r dash? We don't know, but we know r. R is 10. And what is h dash? We don't know, but we know h is equal to 30. So now we know that h dash is equal to 3r dash if you simplify, if you multiply by 30 on both sides. So now we want to find volume at any h dash and r dash, right? So we just substitute our values from this relation. So v is 1 over 3 pi. What is r? Well, r is just h dash over 3. r dash is just h dash over 3. So I just substitute h over 3 squared times h. So 1 over 3 pi times h squared over 9 times h. So if you simplify this, you get pi h cubed over 27. And that is what the question asks you to prove. And find the rate of change of h when h is equal to 20. So I hope this was clear because I'm going to erase this. Because we are given that, right? So, okay. So we want to find dh by dt. So dv, so v, right? First of all, v is this pi h cubed over 27, defined with respect to h. So it's always helpful to find dv by dh. So you have pi over 27, and h cubed, if you differentiate, get 3h squared. So that is going to be pi over 9 h squared, dv by dh. All right. So now that I have this, I know that dv by dt is equal to dv by dh times dh by dt. What is dv by dh? It's pi over 9h squared. And what is dh by dt? We are looking for that. We don't know. And when h is 20, and we know that dv by dt is minus 4 centimeters squared. So let's ignore the units for now and substitute h is equal to 20 there. So it's going to be minus 4 pi over 9, and h, if you substitute 20 here, you're going to get 400 dh by dt. So you have negative 36 divided by 400 pi, that is dh by dt. So dh by dt is going to be 36 by 400. That is going to be 9 over 100. So negative 9 over 100. And you have pi in the denominator. And remember, dh is one-dimensional. Height is in just one dimension. So the units of height is centimeter. So it has to be centimeter per second. So and it has to be negative. Your answer has to be negative because we are substituting a negative value here. So your final answer is this expression. Negative 9 over 100 pi centimeters per second. And that is it. We're done with question 9. Done with question 10. Question 11. We are almost done. So oil is poured into a flat surface and a circular patch is formed. So it's a circle. All right. The radius of the patch increases at the rate. So dr by dt is given to be 2 root r. We'll ignore the units for now. Find the rate at which the area is increasing when the circumference. So 2 pi r is the circumference of a circle, right? That is 8 pi centimeters. So we can solve for r here. And we see that r is going to be 4 centimeters. This is going to be important. Find the rate at which, so area of a circle is pi r squared. Because a is defined in terms of r, it's always useful to find dA by dr. And that is going to be 2 pi r, which is the circumference, right? And actually, instead of substituting 4 later, we can directly substitute 2 pi r. Okay, let's leave it for now. So dA by dr is the circumference at that particular r value. All right. So now, we want to find dA by dt. And dA by dt is always going to be dA by dr times dr by dt. So what is dr by dt? 2 root r. And what is dA by dr? It is this expression. 2 pi r times 2 root r. And substitute r is equal to 4. You get 8 pi times 4. So that is going to be 36 pi, right? You substitute 4 here, 4 2s are 8, so you get 8 pi. You substitute 4 here, you get 2 times 2 is 4, so 36 pi. Now remember, area is 2-dimensional, right? So centimeters times centimeters, so centimeter squared per second. And that is your answer. 8 4s are 32, sorry. 32 pi centimeters squared per second. So we are done. Now, question 12. So we have 2 more questions. Question 13 looks very long. Oh my god. Okay. A paint is poured onto a flat surface and a circular patch is formed. All right. This is the same question, right? So we are given dA by dt. The area of the patch increases at this rate. So I'm just going to keep 5 and we'll figure out later the units. Find in terms of pi the radius of the patch after 8 seconds. So area is equal to pi r squared, right? Area of a circle, circular patch, means pi r squared. So now, let's see. So find in terms of pi the radius of the patch after 8 seconds. All right. So basically, we start with 0, right? Because paint is poured onto a flat surface. So our initial area is 0, and now it's increasing. So we start with nothing, we pour paint on the surface. So now our area starts from 0 and it's increasing, right? So 0 plus 5 centimeters squared times how many seconds? 5 centimeters square per second times 8 seconds. So that is going to be our area of the paint, the circular paint area, right? So second and per second will cancel out, so you get 40 centimeters squared. That is your area, and remember, area is just pi r squared. So now your r squared is going to be 40 over pi centimeters squared. So therefore your r, you just take the square root. 40 by pi centimeters squared. Centimeters, right? Our radius has to be in centimeters. And 40 is just 4 times 10 pi centimeters. So overall, it's just going to be 10 over pi centimeter. So this is the expression that you are going to get. So we are done with A. Find in terms of pi the rate of increase of the radius after 8 seconds. So dA by dt is dA by dr times dr by dt. So we are looking for dr by dt. We know the radius. So dA by dr. dA by dr, I differentiate it here. I'm going to get 2 pi r if you differentiate this. So we have 2 pi r. What is dr by dt? That is what we are looking for. dA by dt is given, is 5. And our r, we got it from part A, is this expression. So 5 equal to 2 pi. R is just 2 square root of 10 over pi. And times dr by dt. All right. So now, we have 5 over 2 pi equals to 2 square root of 10 over pi dr by dt. So I just divided by 2 pi on both sides. I believe I'm going to get a very messy expression. And I encourage you to figure out the expression on your own. But it's going to be 5 over 4 pi first. And you have square root of 10 over square root of pi dr by dt, right? So radius has to be in centimeters. Okay, I wrote that. So I divide by 2 on both sides. I get this expression. And then finally, I will get like this expression. So I multiply by root pi and I divide and I get dr by dt. Another way of writing this is that you can write it as 5 by 4 pi square root of pi by 10 equal to dr by dt. And what should be the units? It has to be centimeter per second, right? Because radius is in centimeters. So that is going to be your expression. A bit messy, but yeah, this is it. And we're done with question 12. And now finally we have... Alright, so we are going to approach, try to solve the final question here. So a cylindrical container. So let's just draw our cylinder of radius 8 centimeters and height 25 centimeters is completely filled with water. So if it's completely filled with water, then we know the volume of water here. That is going to be the volume of the cylinder. So V of the cylinder is just going to be pi r squared h. So pi r squared is going to be 8 squared, h is 25 centimeter cubed, right? Because our units are in centimeters. So if you do this simplification, you're going to get 1600 pi centimeter cubed. All right, so we have used this information already. The water is then poured at a constant rate from a cylinder into an empty inverted cone. All right, so now we have our cone here. And we are given the dimensions. So cone has a radius is 15 the height of the cone is 24 centimeters. All right, and now we take the water that is inside here. We take the water that is inside here, and we try to fill the cone here. So now the cone is not immediately going to be full, right? So the water is going to be somewhere here, and you're pouring more here. So you're pouring more water from your cylinder. So this is going to be your cone. So here's what we know. So if I take this cross section, then this is going to be my right angle. This is going to be 15, the big one. I just took this. This is going to be a right angle triangle with a slant height. I'm so sorry. The blue and the green line should overlap. And this should be 24. But the water is somewhere here. So it has a height, let's say h dash, and an r radius, r dash. So now this forms actually a similar triangle again. So what we know about similar triangles is that the ratio of the corresponding sides. So radius of water, so let me call it RW and HW. The radius of water divided by radius of cone should be the height of the water divided by the height of the cone. So we can substitute the values here. So the radius of water, radius of cone is 15. Height of water, we don't know. Height of cone is 24. And we will keep this for now. All right, so we have used this piece of information. We have used this piece of information. It takes 40 seconds for all the water to be transferred. And it's being transferred at a constant rate. So basically, your volume, dV by dt, so that is the rate of flow of volume, right? That is the rate of change of volume. So this should be the rate at which water flows out of the cylinder and into the cone. So this is the rate of change of the volume of the cone. This is also the rate of change of the volume of the, so this is the rate of change of the water inside the cylinder, and it is also the rate of change of the water inside the cone. All right, for the cylinder, it's negative because it's pouring out. For the cone, it's positive, but it's the same value. All right, so now if I take the negative value, the amount of water that is flowing out of the cylinder, and I take 40 seconds. So if I multiply this by 40, then the whole cylinder is empty, right? Every second, it's losing some water, and in 40 seconds, it's empty. So something centimeters per second times 40 seconds is going to be the volume of the cylinder. Cube. So we'll ignore the units for now. So therefore, I know the expression for dV by dt. So the part A asks me to find dV by dt in terms of pi. It's just going to be 1600 divided by 40 pi. And that is going to give me 40 pi. dV by dt should be in centimeter cube per second. So that is going to be your answer for A. So just using logic, simple geometry, we get this answer. So we are done with A. Now, when the depth of water in the cone is 10 centimeters, so H of W is given is 10. So we can find R of W is 10 centimeters times 15 divided by 24. So this will cancel out. Our radius, we will get it in 24. So 150, right? 150 divided by 24 is going to be 6.25. We know R of W. Now V inside the cone has to be 1 over 3 pi R squared HW, right? This should be the volume of the water inside the cone. All right. So V, I know what RW is. Sorry. All right. So let's just ignore this for now. Okay. So now let's use this expression right here, to write, I know what RW is just 15HW divided by 24. So I will substitute this here. So 15 HW divided by 24 squared times HW. So now that is going to be 1 over 3 pi. 15 squared is 225. HW cubed, we have HW squared times HW over 24 squared. So this is going to give me a very messy expression, but it is going to be 225, 3 times 24 squared. So it's, if you simplify, you are going to get 25 pi over 192 HW cubed. That is going to be your V in terms of H. All right. So now dV by dH, because V is expressed in terms of H, is going to be 25 pi 192 times 3HW squared, right? And that is going to be 75 pi. Okay, 75 pi. I need to do this very quickly. 192 HW squared. I multiplied by 3. Now, remember, dV by dt, which I know, is going to be dV by dH, which I have calculated, times dH by dt. So now dV by dt, I already know is this, 40 pi something something. I'll forget the units for now. dV by dH, I am given HW. HW is 10 centimeters. So I need to substitute 75 pi over 192. I can substitute HW squared, which is 100, dH by dt. HW is 10, HW squared is 100. And now I just need to solve this. So pi will cancel out with pi. So I have 40 times 192 divided by 7500. That is going to be my dH by dt. And when you simplify this, you are going to get dH by dt is going to be equal to 40 times 192 divided by 7500. So that is 1.024, and height is in centimeters per second. Now in the cone, if you pour water, is the height going to increase or decrease? It's going to increase. So your unit here has to be positive. All right, so that is going to be your answer. That is going to be your answer for B part 1. So this is solving B part 1. I'm so sorry, I needed to charge my iPad. So we did part A and we did part B, part 1. So I hope you understood the explanation for that one. So part B question, so part 2 of sub question B, find the rate of change of the horizontal surface area of the water in the cone. So now the horizontal surface area made by the water is going to be pi r water squared. All right. So now if I want to find dAW by dt, which is what the question asks, I can keep pi, right? And now I have, so let's think about this. We need to use the chain rule. A is expressed in terms of RW. So dAW, if I differentiate like this, I am going to get 2 pi RW, right? So now dAW divided by dt is just going to be dAW divided by drW times drW divided by dt. So we don't know this, but now we can make some substitutions. So this is what we are looking for, dAW by dt, and this is what we have. We know this is going to be 2 pi RW times drW by dt. All right, so we are going to use this expression. Okay. So now if my HW is 10, I can solve for RW here. RW is just going to be times 10. All right, so RW, I can substitute it. 2 pi RW, I can easily substitute it as 150 divided by 24. Now I just need to find drW by dt. And how do I find that? I will go back here. V is 1 over 3 pi RW squared HW, right? Now, instead of previously, I substituted RW squared. Now, this time I will substitute HW. So this was HW. So HW is just 24. So HW is just 24 RW by 15, the opposite. So HW is just going to be 24 RW by 15. All right. So now we have if I try to simplify this, I think I will have 8 pi rw cubed over 15. That is, I think, the expression I should get. Now, find dv by dt. dv by dt is going to be 8 pi over 15. You first differentiate this normally, and then you are going to get drw by dt. And we know what rw is. Rw is this messy expression, right? So now we can simplify this. dv by dt I know is going to be, so I know dv by dt. I remember finding dv by dt. Okay, dv by dt is here, 40 pi. I have 40 pi centimeter cubed per second. So I'll ignore the units. I have 8 pi over 15 times 3. So 8 3s are going to be 24 pi rw squared drw by dt. So 15 times 40 divided by 24. So pi is going to cancel out. 15 times 40 divided by 24. This is going to give me 25. So if I multiply by 15 and I divide by 24, I get this expression. And furthermore, rw, I know what it is. It's 15 times 10. So it's 150 divided by 24 squared. So now from this, I know what my drw by dt is. So drw by dt is going to be 25 times 24 squared divided by 150 squared. So that is my expression for drw by dt. So I'll leave you to figure out how I got this expression here. So you just multiply by 24 squared on both sides and you divide by 150 squared. So now I can do some simplifications. These will cancel out. So I have 25. So I have, essentially what I have is I have 2 pi times 25 times 24 divided by 150. 2 times 25, that is going to be 50. 50 times 3 is going to give me this. So overall, your answer is going to be 8 pi. 24 divided by 3 is going to give you 8 pi. And then your units, because it's dAw by dt, has to be centimeter squared per second. And that is it. That is your final answer. And we are done with chapter 5. All right.